critical velocity that is VC. In previous article, for fixation of orbit of the satellite, the three types of velocities are required. One, that is critical velocity, then horizontal velocity, and the escape velocity. That three types of velocity which are required to the satellite to fix the orbit of a satellite as well as for launching the satellite. Then from these articles, then again question is arising in our mind, then what is meant by the critical velocity? That critical velocity is nothing but the horizontal velocity of the projection which will the satellite which revolve in a stable orbit around the earth is known as the critical velocity. The horizontal velocity of projection with which satellites which revolves in a stable orbit around the earth is known as the critical velocity. Then we have to determine the critical velocity at the various points in the various terms, such as the critical velocity of the satellite very close to the earth, as well as the critical velocity on the surface of earth, or the critical velocity very close to the surface of earth. For that we have to consider any types of the satellites having the mass small m, which are placed on the surface of earth. Consider the satellite of mass small m which are placed on the surface of earth. Let capital R be the radius of earth and capital M be the mass of earth. For that, then according to the Newton's law, the force F is equal to G capital M small m divided by R square. That is equation 1. Then according to the Newton's second law of motions, according to the Newton's second law of motion, force F is equal to mvc square by r. That is equation 2. But for the circular motion of any body around the earth, the centripetal force is required. That is CPF is equal to force of attraction between them is. That is equations B. Then from equations 1, 2 and 3 we get. That is z capital M small m upon r square is equal to m vc square divided by r. Then from this equation capital M get cancelled, r get cancelled. Remaining thing is that is z capital M by r is equal to vc square. Then taking square root on both sides, taking square roots on both sides, then vc is equal to under root z capital M by r. That is the critical velocity of the any body or satellite on the surface of Earth. But we know that the acceleration due to gravity on the surface of Earth is, that is small z is equal to capital G capital M divided by r square. But capital Z capital M is equal to z into r square. That is the acceleration due to gravity on the surface of Earth. Then this equation which is simplified, and then value of gm which is put in the above equation, that is vc is equal to under root g r square by r. Then r get cancelled and vc is equal to under root gr. That is the required expression for the acceleration due to gravity. That is required expression for the acceleration due to gravity, or that is required expression for the critical velocity in terms of acceleration due to gravity. Then again such same critical velocity which is determined with the help of that density, that as critical velocity in terms of the density rho. Then or what is the effect of that density on a critical velocity? We have to know that Earth is a solid sphere. Earth is a solid sphere, and volume of Earth, that is V is equal to 4 by 3 pi r cube. That is equation 6. That is the volume of Earth. But we know that the mass of the Earth is equal to mass of Earth capital M is equal to volume into density. That is capital M is equal to 4 by 3 pi r cube into rho. That is equation 7. That is the mass of Earth. Then this mass of Earth which is put in the critical velocity on the surface of Earth, that is Vc is equal to under root the value of capital M 4 by 3 pi r cube rho into capital M Then we have to put the value of capital M. Then Vc is equal to under root 4 pi r cube rho capital M divided by 3. But the root of 4 is 2, and root of that r square is r, and which is taken outside this square root. Then remaining thing is, that is pi, remaining thing is capital Z pi r rho. That is the required expression for the critical velocity in terms of the density rho. That is critical velocity of the any satellite very close to the surface of Earth or on the surface of Earth. Then critical velocity on the surface of Earth is Vc is equal to under root gm by r. Then the critical velocity in terms of gravity or effect of gravity on that critical velocity on the surface of Earth, that is Vc is equal to under root gr, and then the effect of density of Earth on the critical velocity very close to the surface of Earth, Vc is equal to twice r under root g pi capital R rho upon 3. That is the critical velocity on the surface of Earth. Then again we have to see the effect of that acceleration due to gravity and density of the Earth on a critical velocity at height Earth above the surface of Earth. Let us again we have to consider. Let us again consider the any body of mass capital M which are revolving around the Earth at height h. H be the height of that satellite or any body above the surface of Earth and which are revolving around the Earth with a critical velocity Vc. With a critical velocity Vc. Let capital R radius of Earth, capital M mass of Earth. Then at the same time that satellite and Earth which are attracted towards each other with a force. Then according to that Newton's law of gravitation, this force of attraction in between them is, that is F is equal to G capital M small m upon R plus H brackets. That is equation 1. But according to Newton's second law of motion, the force of attraction between them is F is equal to, that is F is equal to m Vc square by here R plus H. That is equation 2. Again, when the satellite which are revolving around the Earth in a circular orbit, then there is a necessity of the centripetal force, and that centripetal force which are provided according to the Newton's second law of motion. Then these CPF is equal to force of attraction between them. That is equation 3. Then again from equations 1, 2 and 3 we get then that is CPF means the centripetal force, that is M Vc square by R plus H is equal to the force of attraction in between Earth, satellite and Earth according to Newton's law of gravitation, that is G capital M small m upon R plus H bracket square, where small m get cancelled, then R plus H and one of the R plus H get cancelled, and then Vc square is equal to G capital M upon R plus H. Then taking square root on both sides, we get that is Vc is equal to under root G capital M upon R plus H. And that is equation 4. That is the equation for the critical velocity at the height h. Then again we have to know that the acceleration due to gravity at h is gh is equal to G capital M upon R plus H bracket square. But we have to simplify this equation for Gm. Then Gm is equal to, that is Gh in bracket R plus H bracket square, and that is equation 5. Then put the value of equation 5 in 4, that is Vc is equal to again under root G, the value of Gm is Gh in bracket R plus H bracket square upon R plus H. Then R plus H get cancelled, and Vc is equal to under root Gh in bracket R plus H, that is equation 6, and that is the equation for that critical velocity in terms of acceleration due to gravity at height h, means that is the effect of that acceleration due to gravity of a critical velocity at h. Again, we have to know that Earth is a solid sphere. Then volume of Earth is, that is V is equal to 4 by 3 pi R cube. But mass of Earth is equal to volume into density, that is capital E is equal to V into rho, that is equation 7. Then put the value of V in this equation, that is M is equal to 4 by 3 pi R square R cube into rho, that is equation 8. Then this value of the mass of the Earth in terms of density, which is put in the equation 4, that is Vc is equal to under root capital G capital M upon R plus H, that is Vc is equal to under root capital G, then value of M 4 by 3 pi R cube rho divided by R plus H. Then this equation, which is simplified, that is Vc is equal to under root 4g pi R cube rho divided by thrice R plus H. Then again this equation is simplified, and that is Vc is equal to the square root of 4 is 2, then square root of r square is, that is r in brackets, that is g pi r rho upon thrice r plus h, and that is equation 9. That is the critical velocity of that orbiting satellite around the Earth at the height h. That is the critical velocity of the orbiting satellite at the various point. That various point means critical velocity on the surface of Earth, then critical velocity due to the acceleration due to gravity, then critical velocity due to the density of the rho, then critical velocity at the height h, that is Vc is equal to under root Gm by r plus h, then critical velocity in terms of gravity at height h, and critical velocity of that orbiting satellite in terms of the density of the Earth, that is rho. In this various point, then we have to get the critical velocity of the satellites. Then we have to get the that satellite which are revolving around the Earth. Then again the question is arise in our mind, then how many periods which are required to that satellite to complete the one revolution around the Earth, means that is the